You're listening to The Digital Factory presented by Formlabs. I'm your host, John Bruner. In this podcast series, we'll explore digital manufacturing and conversations with the experts who are changing the way things are made and shaping the future of the factory floor. In this episode, I'm speaking with Gian Paolo Bassi, the CEO of SolidWorks. Welcome, Gian Paolo.
Thank you. How are you?
Very well, thanks. Excited to talk today. So SolidWorks, since it was released in 1995, has revolutionized the availability of, sophisticated parametric solid modeling and made it possible for a lot more people to enjoy this technology. What kind of expansion are you seeing these days? Are you continuing to see new people begin to use digital design software?
Yes, you said it right. Actually, our mission since the beginning, when we started back in 1995, our dream actually was to put the power of parametric 3D design in the hands of every single designer on Earth. And this is actually happening. We have converted designers from just pen and paper in the hundreds of thousands. But this was just the beginning of our vision, because letting designers to create digital designs or digital representation of their intellectual property is just the beginning of the digitalization and the automation of what we think should be the entire design to manufacturing process. This is the fundamental premise. And we started adding value on those digital assets, being the first in the industry to, for instance, enable designers to do simulation because their designs were in 3D digital format, and because of our vision of democratization of sophisticated technologies. So we wanted to make the tools for the engineers as easy as possible so that they could focus on innovation. And the simulation was the next target. And I would say that now manufacturing is where we're focusing right now.
What kinds of people do you see getting involved in the design for manufacturing process? Does it remain a series of highly specialized jobs with a lot of training, or is the entire design process becoming more informal, more generalist, bringing in a lot of different types of people?
See, what we are seeing in the industry is that specialists of CNC programming, which is the premise of digital manufacturing, are retiring, and the new kids coming out of school have a background that is much more rounded. Today, I would say that mechanical engineers have a knowledge across many more disciplines. For instance, they know about electrical design, they know about electronic design, and they also know about manufacturing. They may not need to know all the details of what it takes to create a C code. They may not know the C code format by heart. But you know what? This is also our role, to simplify the access to those type of technology. And since this simplification is happening, therefore the scope of what designer can do is expanding. And today we see more and more, not mechanical designers, but mechatronic designers. And the trend, we believe, is going to be designers that are fully rounded from design to manufacturing.
So everyone is crossing the disciplinary boundaries.
Yes, everyone, you are completely right, because of the simplification of the tools. Just like my wife is now a digital artist, and she's able to do things that not long ago were exclusive to sophisticated users of high-end graphical design products. Right now, the democratization of that has reached everybody in society. And my wife is pretty comfortable creating digital content, digital assets that she can share with family and friends and so on. The same things, the same trends are happening in the design. You asked me whether these tools were for highly sophisticated and specialized engineer. I would say it is for sophisticated people. So people that are sophisticated in terms of imagination, not in terms of knowing exactly where to click on an authoring tool in order to transfer their imagination into a digital intellectual property. Our job as a software developers is to actually eliminate that distance, close the distance between imagination and digital assets. And since we have been working almost, this industry is very old, computer-aided manufacturing and design, have been working very hard 40 years on this. I think we are getting close to an inflection point. For instance, another analogy which is interesting is think about the process of drawing. So you spend all your time and your energy to create a very well detailed 3D digital model, and then still the contract of reference is a paper drawing, which is nothing else than a very tedious and time-consuming projection of a 3D digital model into a paper space, and then the decoration with all the information that are already captured in 3D for the purpose of printing actual paper and putting a signature with ink on top of it. Now, all this is actually rapidly disappearing because I was not long ago in a tour in Japan, and our customers are telling me that the cost of creating a paper documentation of a design is 3 to 5 times higher than the cost of creating the digital model itself, which is unbelievable. So this is happening, and you can translate very easily the same analogy into the manufacturing world. So what is still happening today is that in part of the industry, and this is why many countries are inventing the digital revolution, they are actually stimulating the digital revolution in their industries. That is why we have Industry 4.0 or Made in China 2025 and so on. It's because you start with your production in digital intellectual property, and then you have to translate it into paper, which is extremely costly. Then you hand over the paper to a specialist that has in turn translate what is described on paper for a robot or for a numerically controlled machine. This is absurd, because the machine can talk directly, the CNC machine can read directly this information from the digital content without any human intervention and without the waste of time, the low level of intellectual property creations that happens in those intervals of time, and most important, without mistakes.
So would you say that then the kind of first phase of development of CAD was the creation of software that could create meaningful models and aid the designer and the engineer in his or her kind of conceptualization process? The next phase, the current phase, is that of filling in the chasms that exist between different steps of the design and fabrication process?
Yes, absolutely. You said it very well. There is a chasm, and today there are silos. For instance, simulation, I mentioned before, we broke down the barrier between the silos of design and simulation. Typically, the design process still is, we are still in the process of doing it, but the process is I design something, then I hand over my model to a specialist that then has to interpret the model, has to do some modifications, some simplification, a lot of iterations, and then come back to me maybe 2 weeks later saying, hey, listen, this thickness is not sufficient. You are getting too much stress here. And then I have to go back, and maybe I don't even remember what was the thickness that was wrong. I cannot do the job myself. Somebody else in another office, maybe in another country, is doing the job for myself. Exactly the same chasm exists between design and manufacturing. And the old story of the manufacturing engineer that goes back to the designer, hey, listen, stupid. If you wanted to do injection mold, you need to have a draft angle. I told you so already. Why didn't you do so? This is a joke, right? Among us engineers, the design engineer that doesn't know anything about manufacturing, and vice versa, because then the designer would say, hey, listen, if I do this draft angle, nobody would buy this consumer product because you know what? Looks ugly. So you'd better find out a way to manufacture it. Now, our dream is to make it possible to make all these decisions in the same brain, in the same context, or among a collection of people that have all the elements, all the recommendation to make an instant decision. And by the way, this is what is happening in many other sectors. So for instance, today, the purchasing power of individuals, the decision-making process when people buy something is extremely faster and easier and informed thanks to the advance of internet, of pervasive computing, the big data, a platform like Amazon, where instantly the best price of anything across the world, So you can make a decision much faster. This is exactly what we are trying to do with basically reducing to zero the distance between digital imagination and all the disciplines that are attached to it to make things happen physically. So I would borrow what Professor Neil Gershenfeld at MIT used to say. We wanted to go from bits to atoms in just a click of a button. And basically we are trying to do that because there are many other disciplines that can be completely automated. For instance, quality assessment. There are machines called the CMM machines that are robots, and still today you have to program a robot to check the quality of a product for which you already have the digital representation. Now, what we are doing is trying to short-circuit this and have CMM machines go interrogate the model, understand the tolerances, and understand the surface finish, and the program themselves.
So this is about shortening the feedback loop from perhaps weeks or months to something where you could imagine hours, right? If the engineer is able to perhaps, manufacture a prototype on his desk, query the expertise of other engineers, do some simulation, it could become an almost entirely digital process.
Yes, absolutely. And in addition to shorten the cycle time, as you said correctly, you can put upfront in the design process information that are critical to inform the design itself. Because if you know in advance that the shape is not going to withstand a given load, you just don't use the shape, you change it. And today we, SolidWorks, we are developing technologies where you can even ask the computers to come up with a recommendation for the optimal shape for a given type of job. If you knew upfront costing characteristics, manufacturing ability, the performance of a material, if you could factor that in upfront in the design process, you would make a much better design. You would waste much less time.
So that the designer is given at the beginning of the design process a sense of what the constraints are and of what the suggested optimums are.
Exactly so. So in fact, and by the way, this is the reason why the mechatronic discipline is emerging. Well, has emerged since quite some time, because at the end, you create a mechanical apparatus that is electrically operated, but you cannot make a distinction between the two because some functions are closely interrelated, like a motor, an electrical motor could be part of the frame. Okay, so the mechanical engineer needs to understand that the case of a motor can withstand some type of load, so you can put it as part of the frame. Is also when you design a car, so the body of the car needs to hold the engine, needs to be strong enough to do a crash, to go across a crash test, but should be shaped also to give some aerodynamic characteristics to the car. So this multidisciplinarity is across everywhere you have the things that needs to be manufactured, and these disciplines are increasing because right now the sophistication of the product is and the innovation is increased. Now every product needs to be connected. The Internet of Things. Now, how do you connect the product? You have to put antennas into product. You have to put electronic into the product, and the location of the antenna can make or break the success of a product, for instance. And then you need to simulate all of that. And then you need to give the designers the tools to be able to predict what is the right antenna for a given product. Because a mistake could be too costly. Or look what happened to the famous phone.
The iPhone, right? That the first iPhone 4, I think.
Exactly. Well, that mistake has been discussed in the industry for many, many weeks now. And the result is that it was a poor integration of parallel disciplines. Electronic and mechanical did not connect well. And the contact would create overheating and eventually would make some component explode. Mm-hmm. So we see before us the cost of lack of integration.
Now, we'll keep talking about the future of design and engineering in just a moment, but first a reminder to the listeners. Join Formlabs on June 5th in Cambridge, Massachusetts for the Digital Factory, a one-day conference on digital manufacturing hosted at the MIT Media Lab. Intermingle with business pioneers, investors, innovators, startups, and thought leaders reinventing the factory floor. See the full agenda and get your ticket at digitalfactory.xyz. Use the code TDFpodcast for a 50% listener discount. So when we talk about this multidisciplinary approach, it makes me think of software, and I've seen this movement in the physical engineering disciplines for some time, where you can begin to sort of extrapolate and see that they're moving in the direction of software, where everyone can be sort of a generalist and a specialist at once. If you are an experienced C++ programmer, it's fairly easy to become a Python programmer. If you are a front-end JavaScript developer, it's fairly easy to become a back-end database administrator. And so there's this idea of the full stack engineer in software, someone who's proficient at, many different sub-disciplines. Do you think that mechanical design and kind of the physical engineering disciplines and mechanical and electrical are headed toward a similar convergence?
Yes, absolutely, because this is happening in the consumer space. So the convergence of all those disciplines are already. So today there is no product that is successful unless it is fully automated and fully connected. These days, if you buy a light switch without the ability to operate it remotely with an iPhone, you look like a Neanderthal man, I believe that the concept of stack and the concept of seeing through, the inventors, the designer that is able to own the entire discipline, I think the stack of the disciplines to make his product happen is happening, and also is making it possible, because if you look at the society, there is a huge appetite for entrepreneurship today, and the barrier for individuals to become entrepreneurs are lowering, because individuals are able to gather the skills and the knowledge and the experience to make things happen, even in the sophisticated world of connected objects, of consumer products that are very, very much advanced. So today you don't need to be GE to create a connected smoke detectors. Everybody can do it because they have the knowledge, the capability to see through the stack of disciplines and technologies that needs to be put together. They've studied it at school, they've done it, and they have the tools to do a prototype. Today, we see our customers that are able to create the first prototype in a garage, a first prototype of a very sophisticated object, like, for instance, the freight farm. I don't know if you heard about this connected object. Is basically a freight containers that is converted into an urban hydroponic farm, and it is fully operated by a phone. And this was done by a couple of kids out of college that knew that it was possible. They were able to put it in practice, and they were able to create the first prototype at a very, very low cost, thanks to the access to technologies and tools that were able to help them design and simulate everything that they wanted to do.
And you mentioned connected devices and the Internet of Things as well, which is kind of the imperative behind a lot of new product development. There's a lot of demand for objects which are, commonly available to be made available again with Internet connectivity in them. So this is changing the necessary stack once more to include software and connected software, not just the kinds of embedded electronics that people are used to working with in these product development cycles, but also a sense of web software, right?
Yes, and the connectivity itself in situations of high latency is very challenging, because how to make sure that you operate instantly your switch, or are you instantly notified whether your cat gets into the house? We have a customer that has created one of those small doors, that are created for the pets, and this door is completely connected and is connected to the cat itself. The cat that goes around with the sensor, so that your cat can get into the house and not somebody else's cat. And of course, and all this is orchestrated through the cloud. All this needs to happen in situation of high latency. So there is a lot of knowledge and a lot of disciplines. Luckily, there is also a lot of experience out there. There are companies that have been connecting remotely with the computers for many, many years. There are the telecoms that manage sophisticated cellular networks that know how to do those things. But the convergence is the news. I mean, not long ago, the connected devices were the portable phones. Right now, everything it is, and we can piggyback on the huge experience on large, sophisticated networks that the telecom have created in the years. But the convergence is the right keyword. It's happening across all industries.
So let's talk about what's coming up next for SolidWorks. What's the single biggest demand from your customers that you hear most often?
Our customers are asking right now one and only one thing. They want us to help them be more innovative. Not long ago, it was a different conversation. They wanted us to help them to be more productive. And now this is different. This is changing. They don't ask us about squeezing time or reducing the number of clicks, and not even reducing the cost. I mean, the cost is not a big factor these days. The real imperative is innovation. Because, as I said, the barrier of entry for new entrepreneurs, those barriers are lowering by the day. So the incumbents are challenged every day. And the only way to survive and the only way to thrive for companies is to be at the leading edge of the technologies, and also, I would say, of the imagination, because sometimes you don't need a new technology to be innovative. You just need to put it together in a better way, or create a service, or add a service in a sector that was not possible. Think, for instance, what is happening with industrial equipment, that by being connected allows preventive maintenance. So this innovation is really changing the industry. So I believe, again, our customers are asking us to be more innovative. And this is a big challenge because we are not experts of their domain. So we started analyzing what are the elements of innovation. How can we help our customer be innovative? Even if we are not a subject matter expert of what they do, we cannot be expert in industrial equipment or high tech. We are in 12 different industries, And the answer is that we analyzed all these customers, we analyzed the best practices, we spent quite some time with smart people across the world, how they've been successful. And we believe that there are two answers for that. One is collaboration, and the other one is access to resources. Access to resources that could be physical or in terms of skills. And we believe that we needed to focus on a platform type of technology in order to expand the horizon of the imagination of our customers to be more innovative. So, for instance, let me make an example. Let's say I have an idea and I want to manufacture something. How do I know that this thing is manufacturable? So, well, the first things that you can do is to Google it, okay? But Google is not specialized to help manufacturing or designers, okay? You can Google something, material, and you get a bazillion of things, usually commercial offers. But you don't know what is the lowest possible thickness that you can go with a specific plastic and who can do it for you. So we are creating all this kind of support ecosystem. We wanted to have it intimately connected into our software and therefore available to our customers, to the designers at the click of a button. And we are helped by a lot of very visionary partners of ours that are already doing this. Let me make an example. Okay, we have partners that are right now creating plugin into SolidWorks so that it's easy for one of our customers to get a quote and to get desired recommendation on whether these things can be manufactured in some outsourcing situation, some contract manufacturing situation. So for me, this improves the chances for innovation because in a few clicks, you can have a quote and you can know whether your product can be manufactured, it can be done, and what is the cost. And of course, the pricing is extremely important for entrepreneurs to make an innovation decision because sometimes innovation is just in the price point. So, for instance, when cellular phones became available at the price point to the vast majority of people, it became a huge business and it went on to saturate the entire world. Now everybody has 1, 2, 3, or 4 cell phones because of the cost factors that went down. But if you don't have this knowledge, it is difficult to innovate. That's one thing. The other thing is many entrepreneurs have limited resources, have limited skills, and they need to gather those skills and to look for advice on a worldwide basis. How do you do that? How do you create a network of people that can gather around your idea and become perhaps partner of yours, whether they are located next door or they are on the other side of the world? So we see this happening every day, and we see the need for us to provide tools that make it happen. So basically connect the ecosystem, create a marketplace of capabilities, of expertise. It's even very important to be able to find a part that fits your, let's say I need an actuator, I need a motor, I need a pump. Where can I find it? And more often than not, the lead time of delivery is a fundamental factor in the decision because it can solve the problem. So how do you do this in an integrated environment? Again, you can go and Google it, but then you have to pick up the phone. Maybe you don't speak the language. Maybe you send an email, but maybe you don't find the email. So, I mean, it's not designed to to help people innovate. This is what we are trying to do, to be the Google for designers and innovators.
So it is, again, fundamentally about crossing the chasms, not only between, design and engineering and manufacturing, but also between the different disciplines, between the suppliers and the designers, between different components of the manufacturing and engineering and design processes.
Yeah, you're right. At the end, we like to call it the power of zero, so reducing the distances. And we have been inspired by what's happening in the industry today. So look at the revolution of the transportation industry introduced by the simple invention of a platform like Uber. Of course, everyone talks about Uber. Uber is not a taxi company. They don't own any single taxi. They don't employ drivers. They have created the platform. Same story, Airbnb. They don't own assets. They don't own hotels or other physical assets. They have created a platform for people to share. And this is going to help a lot of situations. It's going to help tremendously development countries and also redistribute opportunities in developed countries. There are many people today that find opportunities through this platform. And we see customers that, for instance, think about a manufacturing shop in Michigan that has excess capacity. How is he or she able to reach customers on the other side of the world for a small run, for instance? If you don't have a platform that help you makes those decisions, it is very difficult. And this shop in Michigan maybe has a lot of lost opportunities because nobody's helping him connect the dots. Just like a kid that has some spare time and the car can make some money by driving someone at a better pricing condition and many other better conditions that I can tell. I'm a big fan and user of Uber. It's exactly the same thing.
Gian Paolo Bassi, CEO of SolidWorks, thank you so much for speaking with me today.
Thank you very much. It was my pleasure as well.
The Digital Factory podcast is presented by Formlabs, makers of accessible, precise, reliable 3D printers for the desktop. Visit formlabs.com to learn more, or head over to digitalfactory.xyz to get your ticket to our one-day conference on digital manufacturing at the MIT Media Lab in Cambridge, Massachusetts on June 5th.